What's up? Good morning. So I think what I want to do today is start to work on a little bit of collisions. Hey, GL Dev. So yesterday, toward the end, I think you came in toward the end of the stream, GL. But we were working on just getting some of the background elements up, because it kind of helps to solidify the fact that we are making something. So there's quite a few layers in here. There's a foreground element with the characters, and then a ground plane that your character runs along. We've got this layer here, these little barrels. So they're just repeated tiles, then this fence. And then behind that we have a another layer with the buildings. And then some people are saying, because in the original, these two background elements, the sky and this layer, are together, but some people are saying that looked kind of strange, so we went against the original and we kind of separated these out. So now we have these layers that are moving differently as well. Bitmask collisions. I don't know. I don't know how exactly I'm going to go through and handle this. I think really it just needs to be something simple, like simple AABB collision tests. Don't necessarily need to. I mean, I guess we could do bitmask collisions for certain things, right? If we have like pickups, we don't want the enemies to collect. But it's not even necessary that it's bitmasks. And then we have, we hit I for information. We'll have some debugging information. I think what we'll do is actually draw out kind of a quad down here to show where the ground planes are. Yeah, what I think I'm going to do is just put like an AABB collision strip somewhere in the world, probably sitting on the ground plane, and we'll just have the player run into it, and players shouldn't be able to intercept with it. Should be fairly straightforward. And then what we'll have to do is go through and start actually filling this out with just whatever, player information. Make this to where this is infinitely scrolling. Right now, what I'm doing is kind of cheesy. I'm let's go to the render. So for the quad batches, we have a player quad batch, and then we have a background quad batch. And so right now for the background, I'm just filling in all of this quad batch information, just filling it with a bunch of different instances in order to fill out the layers. But the downside of that is that there are bounds that you can actually see that you can run into. So it's not infinitely scrolling. So what I'll probably end up doing is having something that's more procedurally done so that it's completely based on the camera. I also like this. So one of the downsides of the original Contra being a 4:3 resolution is that the zoom scale for the camera is about this, so it feels pretty claustrophobic. But I mean, most SNES games did. But it would be kind of nice if it could kind of be out here with it. But that completely changes the game, so might not do that. We might just go with this. Because one thing is I don't have background elements to fill all this out. So, although we could do like extend this all the way down just to this color, and then do foreground elements that we make ourselves that could be kind of parallaxed, which would be kind of cool. Maybe blur them a little bit. But at that point, we're kind of taking more and more artistic license, and yeah. But that's where we are now. So I think I'm just gonna start working on some collision stuff. I did clean up a little bit before the stream. So if we go into the player, I created this AABB structure. It just holds the bounds for the player's collision struct. And then in this get the window bounds, we're just grabbing that AABB information. For the player's update, we update movement, and then we update the AABB information there so that we can use that for later on, and then we'll handle world collisions here. All right. So I'm just going to start working on stuff. I thought the parallax was procedural. Not yet, but it should be easy enough to do that. The thing is, they're all background elements, so I don't really care about it too much right now, because they're just going to be infinitely scrolling background elements. And then they're kind of placed oddly, because right now they're placed based on factors of the camera. Which is fine. I mean, that's the way the math works out anyway, but I'd like to be able to have more control over it. So what we'll do is we'll do it based on the Z of the object itself. So we'll actually place it back in the world. And then we'll change its position based on that. And then I'm getting to a certain point where I'm going to start ripping some of this out because the file's getting kind of long. Suppose what I could do. I don't really care about that right now. So let's just do, so we have global here. Let's just put like a global AABB. How do you compile? Just using a batch? Yeah. Yeah, just have just a bat script. So here's the Windows. Very straightforward. Here's OS X and then Linux. Very little required to get it all compiled. All it does is links against Gunslinger. That's all it needs to. And then whatever other system libraries that are required for like a standard 32-bit or 64-bit program. Do you only use C++ for IMGUI? Yep. That's it. I would jump over to using Nuclear for this, but I don't know Nuclear as well as I do IMGUI. I've used IMGUI for a few years now, and it's really straightforward. I can do a lot with it. Has a lot of good debug operations that I'd like to use. So either in the future I'd like to use Nuclear because it's C, or writing my own. Done it before, but it does take time. So it just kind of depends on what is useful for you guys, what you'd like to see. Yeah. Because if you want me to focus on doing stuff like this, then maybe spending the time to focus on writing an IMGUI API or an IMGUI system for Gunslinger wouldn't be worth it. But I don't know. I'm on the fence of doing entity component stuff for this as well, because I don't know if it's worth it. So we want some world space bounds for this guy. Using GCC on Windows too, right? Yep. Well, hold on, let me see. Actually, I think for Windows for compiling, this is all MSVC. So, yeah, this is using CL. So this is using MSVC. But again, nothing keeps you from, I mean, if you want to use GCC or MinGW or whatever else, just write a batch file that compiles with that. Simple as can be. I used CMake for the longest time, but those build systems get ridiculously complicated and unnecessary. So you start out using simple batch files to do stuff like this, and then you switch over to like Visual Studio, then you switch over to CMake, and then you just make your way back to using batch files. That's the progression. Because at the end of the day, dealing with someone else's build system is annoying. So where do we want this? Maybe we should let's print out the player's transform information. So let's do that. So this is why we have our debug window. Player transform information. So we'll do IMGUI text. Or I guess we could do a collapsing header. Right? Isn't that what it, collapsing header. If IMGUI collapsing header, we'll do player. I don't think we need anything like that. Just make sure that's the correct way of doing it. Nope. Oh, there's a macro issue. What am I missing here? Oh, okay. Hi there. Good morning. So you got a player. Cool. Let's go ahead and do the same thing for this. And then for the player, we'll start capturing that. I don't need to. For the player, we'll do like transform information. So let's see. How do we want to represent the transform? Slider float. Does that compile? Do I have to give it a min-max? Is that okay? Nope. Oh yeah. Slider float. No, yeah. Has to be min-max. So I would really like the world to start at 0. So we're gonna make that work. Alrighty. Remake is looking good so far. Thanks, man. Appreciate it. I don't think Z will do anything. Z was just gonna, if we do Z, since we're using an orthographic view, he's just gonna disappear if we're not on. Yeah, so our camera's just going with it, and so all the background elements leave. Oh, that's interesting. It's quite a bit different. Yep. So the ground element, I really want the ground to be 0 as well. Just make things easier. Ground level. I do not want. Here we go, but that means that our offsets for all our background elements, they need to be raised by ground level. So we'll transform that up. So when we come into here and do all of our background stuff, so there's the player. Let's see. Origin.y plus ground level. X offset cam origin. Origin.y. Probably to clean this up, we probably will go with like a simple entity system. Make all this stuff a little cleaner. That's good. It's probably, I guess, just minus ground level. Oh no, because it's at 0. Let's do that. I'm have to refigure these. What's the music in the background? What am I listening to? Laserhawk radio. I like Laserhawk. How do you debug it? I'll pull up MSVC if I need to. So if I need to step through something, I'll have it compiled, making sure that I'm compiled debug, which I'm not here. Let me look at I always forget this. So I go to it was Dance with the Dead. Oh yeah, okay. Cool. Good ear. Yeah, so here's the debug macro, or debug. So I'll do a debug compile for this, and then I'll pull a dev environment. Which actually, I think you should be able to do, let's see, dev environment, bin, Contra, and it should pull it up with that loaded. Yeah. So now I should be able to start it. Oh yeah, but my path is going to be weird. So the asset path is expecting me to not load from the bin directory. It's expecting me to load from the root directory. So one of the annoying things about that is that I'd have to, whenever I actually go to load files. So for this, I would have to look from 2 different locations to make sure that these load correctly. So you can still do full C step-by-step debugging. Yeah, exactly. If it comes down to that. Which it does eventually. I mean, you kind of have to. Yep. But I don't have to program in here, which I like because it's slow. What was I doing? Oh yeah, so trying to figure out this. So the ground level used to be at -3. So if I do -6. Oh, damn it. What is this? That's the floor. Let me get the sky. Should have done this yesterday. Ground level's nothing. It's just the fence. Where's my sky? So this is buildings. Alright, that looks right. Maybe not quite that. Alrighty, and then my floor. That's just the Oh, am I doing this twice? No, it's two different things. So I don't know what this is. That's good. Let me figure out what this is. Oh, this is the, I know exactly what this is. Yeah, it's the barrels. So lower, let's do 6. You still play video games? No, I don't have time. Don't have time. And then when I play, I get depressed because I know I should be working on something. So, maybe not depressed, I just feel like I'm wasting time. Alright, that looks fine. And then, whoa, what was it, the sky? So, oh. No, the sky looks good. The, yeah, the sky looks fine. It's the ground that looks bad. Nope. Drop it down a little bit. Oh. Yeah, almost exactly. All right. I think it looks okay. Same here. I miss enjoying having fun though. Yeah, you just have fun in different ways. You know. Okay, so that was a big just clean up because I just wanted the ground level to be at 0, which it is now. All right, so now that we have that, yeah, this all has to be cleaned up. Let's do this guy, and then we'll draw him on the screen. And then we'll get the player to interact with it. Again, this is all prototype shit, just getting it working, right? And then we'll clean it up and formalize it later. But the last thing I want to do is come up here and start, you know, formally defining, oh, this is a collision component, and it needs to have this and this and this and this. And, you know, let's just get it working first, and then we can formalize it later. So let's see where we are in the world. We should start printing out player info. Where do we want something? Let's just say, let's put something at like 9. Right, make it work, then make it work well. Yeah, and then make it pretty, you know, if you care about that kind of thing. Let's put something for the men. Again, this is going to be at the top left, and we'll go to bottom right. So the bottom right. Where do we go? Bottom left to top right. Yeah, I think we're doing it that way. So the min should be 9, 0. And then we'll stretch out. Doesn't really matter, but we'll go to let's just say 10. We'll go 15 to 5. So we'll have a unit square at 5, 5. That'll be in world coordinates. So don't necessarily need to worry about doing much transformation. And let's make a get window coordinates of generic AAVB, right? So we'll do GS vec4, so collision bounds, and we'll do AABB window coordinates. Okay, and then we can do the same thing with the player's AABB. So we won't do player get bounds, we'll do AABB window chords AABB, pass in the camera. And then I could do this. Yup. And that should be it. So let's move this up here to where the ABB is. All right, now it's a little more generic than it was before because it'll work for 2 different versions. Still works, cool. But now we can use it to do this other guy. Which he's right here. Interesting. So it looks like the players transform. Let's draw AABB for ground plane. So what do I want for the ground? Let's go from 0, 0 to, I don't know, 1,000. Let's go below it. Or I guess, I don't know, let's see. Yeah, so it needs to be below it. So okay, so 0 is right here, so the player dips below that for some reason. Well, that makes sense. No, that makes sense. That makes sense. That makes sense. Because the player, the quad batch that I'm using, it doesn't go from 0, 0. It actually starts at negative 0.5 to 0.5, right? So the center is going to be the center of the player. So what I could do is raise the player up. Let's just do that. I want the ground plane to be at 0. It makes everything a lot easier to wrap my head around. So what we're gonna do is for the player's position, it's not ground level. It actually needs to be 0.5. Actually, is that correct? Let me see. Yeah, so the player actually needs to be at 0.5. And now I just need to raise everything up. So all those background elements need to be raised back up again. But that's fine. Instead of 0, we're doing that. Instead of 3, we're doing 3.5. 3.5 here. 1.4. 0.5. That's 9. Okay. Alright. Hopefully that made sense. But I wanted I want the ground plane to be 0. The player's 0 coordinate in his object space is the center of that quad, because the vertex definitions go from negative 0.5 to 0.5. So I needed to raise him up, and then I need to raise everything else up so that it's actually sitting on the ground plane. But okay, so here we have an object in collision space, right? So we have this big hulking object that's 5 units in world space. And then our player is being represented like this. So what we want is, whenever we collide with something, we want it to be able to push the player back. So we want to detect that a collision has occurred right here. And then we want to resolve that collision by looking at, there's a couple ways to do it, but the way that I've done it in the past, and I think the way that'll work here, is that we'll look at a minimum translation vector, which gives us the edge that we're interested in, and then we're going to push them out based on that normal. And this only works for AABBs. When we start getting into rotated quads or non-axis aligned bounding areas, then you kind of have to do different things. So GJK is one of those, where you look at a bunch of different collision axes and then you resolve based on those. Okay. Let me get some more coffee real quick. In the meantime, I'll just pop up a article that we're actually going to use. Let me see. So this is how we're going to handle all this. Are you going with quad trees for bullet hell? Yeah, there'll probably be some kind of spatial partitioning. We'll see. Really, the spatial partitioning will be in case we get to a particular level of complexity where there's just way too much going on and it's starting to slow us down. If we could have, you know, thousands of, collisions where we don't necessarily need to worry about that, then we could just go with that route. We don't have to implement any quad trees. I am all for the simpler solutions, because at the end of the day, the user doesn't know. That being said, we're writing this from scratch in C in OpenGL, so. All right, so let's look at this real quick. So in his case, the only thing that we're going to be able to get useful out of this is checking the collision, but there is minimum translation vector. So we get a minimum translation vector, we get the access to that, then we get the penetration amount, and that tells us how much we need to move. Yeah, so non-continuous. Which I did something similar for the zombie collisions as well, so I can pull that up. If I remember where I put it. So this is for the game jam I did with Miz. And let's see, there was a player versus level. So yeah, we find the MTV here. So we for this it was pretty simple. You get the ABBs for the collisions that you're interested in, and then we find the MTV vector, or the MTV, which again is a minimum translation vector. And then you have to check for certain edge cases with AEBBs, in that case these right here. So this gives you collision information, which lets you know the axes that you're actually intersected on. And again, this is certain edge cases. You want to flip certain areas in case they go outside of certain bounds. And yeah, so this actually, all this is determining MTV, right? So that's what this entire thing is. This rect versus rect actually gives you collision detection. So this lets you know whether or not two different quads are intersecting, if the max of one particular quad is greater than the min, and vice versa. It's fairly simple to visualize. So if we have if we have two different quads here, oh boy. Okay, another one here. We're gonna look at, so the min and the max for both of these. So let's just call this a min, a max, b min, b max. So we're going to compare these two, and we're going to compare these two. Right, so if this crosses this, let's say on the y plane, right? Or the y-axis, rather. If we cross that, then we know that there's a level of intersection that's occurred right here. Okay, so we have one level of intersection, and we need two. And then we look at the x, so we can compare this and this, and we see that along that axis we don't have any collision that's occurred, right? There's a separating boundary between those two. So because we don't meet both conditions for those occurring, then we don't say that there's a collision that's occurred. Actually, I think you need 4. Yeah, you need 4 cases to be met for this. So it's the Amax, the Bmin that have to be checked against each other, both in the X and the Y, and then you have to check the X and the Y for the Amin and the Bmax. Now if we look at an instance where they did collide, so we could have something like this. All right, so now we have a collision that's occurred along this vector, or along this axis. And then checking this axis, we also have a collision that's occurred around those as well. So here's our collision space. And so now we've determined. So the interesting thing for this scenario is going to be, after that, you have to define, again, what the minimum translation vector is for each of these. So you have to determine how much in this direction you're going to push out, and then how much in this direction you're going to push out. And so for a case like this, it's going to be some combination, some linear combination of these two vectors that's going to give you something that kind of looks like this for both of those. So they're going to resolve outward like that from that corner. And again, we're not doing any rotations. We're not doing anything that's going to involve anything other than this simple AABB check. As soon as we start doing things like rotated quads, then all of this goes out the window. This doesn't work anymore. This is just strictly axis aligned bounding box collisions. And that's what we're gonna use. So let's define a couple of things here. Let me get this back up. Again, we're going to check these cases, right? So we're interested in Amin versus Bmax, and then Amax versus Bmin. And we're going to check those on both the X and the Y. Okay, and that's all you have to do for collision detection. Very simple. And again, this is 2D, so it's rectangle versus rectangle. For 3D, this is different. You'd have eight bounding areas you'd have to check. right? And then we need to get from this the MVT. So that'll give us a vec2, AABB MVT. We'll do this. And again, we're looking at the translation vectors. And we want to see if the bottom is greater than the top. So for this, we're going to set our return MBT. Let's actually call that an MBT. And if our left, if we have more to move in the left than the right, we're going to set it to that. And then the otherwise, we'll do the, we'll flip that in the Y direction. And then I'm not sure if we want to do this actually, because this is going to lock X and Y to being one particular area. And we might actually want a vector that isn't just along a particular axis. We might want a combination of the two. So cross product. I'm not sure what you're asking. If you're asking this is a cross product. All right, so now we have those. All right, so let's not call this A. Yeah. That's good. So let's just do this. Let's just determine that we've collided. So do UI. And then we'll change the color of the player if we have collided. So if we did collide, we'll just do red. Otherwise, we'll do white. So we should be good till we hit here, and then we've collided with this guy. And we should be able to raise the player up. 2.5. Let's go 3, 5. So right here, we're just touching it. So as we're running a little bit, our bounds are kind of going up. Might be something we want to fix. But we drop them down to 5, then we're colliding this entire time. Okay. Okay, and now we should be able to do up here for the player. So if ABB versus ABB, player dot ABB, G collision object. Oh, that's down there. So if we do that, get MBT, then move player by MBT. So let's see what this does. Good chance this will completely mess up. So MBT is ABB, ABB, MBT. And we just want to, hey Ratchet, it's going well. So what we want to do is we actually want to just add this. So the player's transforms position, and we'll set this. Set that, and then we'll create a new v3, which is our MBT. Okay, so that dropped us below. Let's raise the player back up. So it's gonna throw us below. So let's look back at, it might need to be might be a sub thing, because the order of this is going to matter. All right. That doesn't look right. Let me see. Oops. Yep. So let's go to Photoshop real quick. Think about this. So for this case, right? So we have a min, a max, b min, and b max. So we want to find the difference between these two. So the left is going to be no, that's not correct. It's actually right here gives us this span. So it should be A max minus B min, and then R should be B max I don't know if I know. Because it needs to be. And then the top. These actually need to be swapped. Right? I think that's correct. This will drop me below. Oh, there's probably something here. There's probably an issue of maybe the way I'm defining. Let me think about this. I think it's the way that I'm defining the quad. So the player's ABB. Let me look at this. Because I'm going top left to bottom right. Really, I want to go bottom left to top right. I think I have these switched up in world space, and I think it's gonna screw up my calculations here. Negative 0.45, negative 0.01, 0.451. So that does look like it's going here to there. Which is what I want, but then if I look at Oh, that's interesting. Wait, what? Oh, duh. Yeah, that looks fine. So 10.0 to 15.5. So we're going up and to the right for both of these. They're increasing. So that's fine. Yeah, it's perfectly fine for both of those. So the min should be the top left. Again, this is a misnomer. This is actually bottom left to top right. Hey, VMA. So let me go back to the MBT. So this MBT is acting strange. No. Let me look at this real quick. I might just devise my own MBT. Or MTV, not MBT. Because really just have to project along those axes the penetration amount. So if we go back to here, so in this instance, so let's say this is B, this is A. These are min and our max. No. Our min and our max. Min and our max. We're interested in this area, right? Because we're trying to define this square. So we want to know the left, the right, or the left, the top, the right, and the bottom. Of this square. So to define the left, it's going to be the max let me see. So we want to do yeah, it should be that. So left should be B max minus A min. So we should be able to look at this corner, which is our B's max, and then look at A min, and that should give us this guy. I'm not 100% certain about that. T should be yeah. And R no, it's not right. I've got it defined over here, but I just don't know if that makes sense. So this is B max. Really, it would be A max dot X minus B min dot Y or X. To define this guy, so B min A max, and should give us, yeah, that gives us that difference, but I don't know if that gives us, but I guess we do just want the distance, right? We just want that distance, and we want this distance, we want that distance, and we want that distance. So max minus min should give us this in the X direction. Same thing here, but it should be min or B max. Where's that? Should use that direction. Because again, we just want, yeah, we just want a translation amount. So again, if I look at this, so L is B max minus A min, the X, or T and our R should be A it's just pushing me down. Okay, well, let's go ahead and raise just for debugging purposes. I can't move up into this, which is fine. But this is throwing me down. And quite a bit as well. Yeah, so it's just kicking me out. So it's like the Y's need to be flipped. So instead of this, it needs to be min and max. Jesus. Yeah, it's a lot. Oh, wow. Yeah, those are opposite. So it's like these two are flipped. It's interesting. Do these need to be flipped? For some weird reason? Okay. Let's move this guy closer. Tired of having to walk, so let's do. Let's just make this a unit cube or unit square, and we'll set them at 2 and closer to the player. Yeah. What's up, bro? Moment. I'm trying to work on collisions a little bit. So this works fine. So going up, that one's jumping me down whenever I go from the left side. And it's kicking me out. I hate collisions. Yep, me too. Thing is, I've done 2D collisions, at least just with AABBs, probably like 3 or 4 times now, and every single time it's different. There's always something that's weird about it. It's not like graphics. I can wrap my head around graphics really easily, but for some reason stuff like this just always does me in. I don't think this matters. Let's go ahead and print out the MBT. I keep saying MBT. That's not what it is. It's MTV. I mean, it's not even useful to print it out. I mean, we know where it's gonna. Why that much? Oh boy. So why would that jump down like that? Oh, this is wrong. So that's good there. That's good there. That's good there. But then this jumps me. And then that jumps me. Okay. I think I have this stuff wrong now. So I'm gonna put this back to what it was. So A1 min, A1 max. That's right. And then A1 max. Min max, min max. All right. So for some reason the top's not working. So these are good. But this top one's incorrect. Oops. Could it be because of the scale drawing? No. No, it should be fine. I'm keeping track of which space I'm actually using this in, so I'm doing all these calculations in world space. So the two AABBs. You can do, by the way, you can do collisions in whatever space you want to, right? You just have to make sure that the two are lined up. So I could do these all in camera space if I wanted to. It'd be kind of strange, but I'm making sure that these AABBs or these bounding boxes that are defining these two objects are in world space, and then I'm doing the calculations based on that. And they're working okay. I just think I'm doing some of these calculations wrong, so I'm just gonna recheck some of my previous stuff. Yeah, that looks okay. I thought. I don't think these need to be swapped, but okay, they do. Well, that's interesting. But I suppose that's because of the discrepancy between drawing and the world. All right, so now we should be able to do, let's do, so instead of this, let's do a dynamic array. Let's do 100. Where do you want to place these? I'd really like a random value. Let's just place them on the floor, and we'll do like I times 3. Real creative here. And they'll each be 1 by 1. That's fine. And then we'll pass that into our array. Collision objects, ABB. Okay. trying to do this real fast. Let's see if it works. Alright, let's go ahead and draw this guy. Okay, we got the player. Okay. So we're going to check the world against every single object that I've placed. Wow. So we should have, yeah, like 100 different objects, and then we should be able to collide with every single one of them. Looks like it's working. And we can still go below the ground plane, but I could set that up as well so that we won't be able to go below them. It's not drawing the. Let's see, why aren't you drawing? Player color. Oh, because I'm redefining something locally. All right. So now we should get, yeah. Cool. There's still a. I think that's because that's just debug information. So I'm drawing that after the fact and then resetting it, right? Yeah, because I'm not resetting the player AABB. So let's do that real quick. Because then this will never change, actually. So if I update the player, AABB updates, and then I would need to re-update the down here. So let's call like and then we'd have to do the same thing in here. And that should be good. That updates all of that. So we update the player AABB because we've moved, but then when we do the collisions, we're going to need to re-update the AABB. Now we won't ever get our collision information, our collision bounding box to turn red, because for that frame we're not actually jumping into it. So all we're doing is just colliding now, which that works fine. So now these collisions work as expected. And again, we have, you know, 100 of these just placed throughout the world, all on the ground plane. There we go. then I think that's it for now. I might jump on. I might do a surprise stream later on today. We'll see how much time I have. But for now, that's really all I wanted to handle. Is kind of get these basic collisions set up and working, and they're working fine. And then if I do another stream today, it'll be just cleanup, and then maybe some, you know, goofy fun stuff. Who knows? But I'll stick around for a second for questions. You guys have any? Yeah, I understand that. All right. Well, I think I'm gonna call it for today. But like I said, I might jump on a little later. It's kind of a light work day today, so. But all right, I'll talk to you guys later. Bye.